We are working on 2.1 writing equations. Our learning goal for right now is that we are going to translate sentences into equations and vice versa. Now, in the past, we've done translating before. We've translated sentences into expressions, but we haven't done equations yet. When we talked about the differences between equations and expressions, again, the difference is that equations have equal signs in them. So, for example, if I had 2x plus 3 equals 9, okay, that's an equation because it has an equal sign. If I just took away this part right here, 2x plus 3, that's an expression. So all of the ones that we work with today are going to have equal signs in them because we're working with equations. All right, so translate the sentence into equation. 5 times the sum of a number and 4 is equal to 3. We're looking for key words right off the bat. 5 times, well, that's obviously going to be multiply. Equal to is going to be our equal sign. Sum is addition. So we've got pretty much all we need. I think that's all that we can see that are going to be like symbols. So 5 times, that's obviously going to be 5 multiplied by the sum of a number and 4. Now, when we talk about the sum, it's the answer to an addition problem. And so there is a tricky little thing to this that we need to kind of hang on to. 5 times the sum of a number, so it's 5 times the answer to an addition problem. And the addition problem is between a certain number, we can call it whatever, I'll call it n, and 4. So these two things are going to get added together, but the point I'm trying to make here is that it's actually 5 times the answer to something. Basically saying we have to get the answer to that first before we can multiply it by 5, if that makes sense. We need to add the n in the 4 before we can multiply it by the 5. Well, with order of operations, we always know we have to do multiplication first. So in this case, we're actually going to do the n plus 4 before we multiply it by 5. So I could put a multiplication symbol in there. That doesn't actually look the best, so I'm going to actually erase the 5. I'm going to write it right next to my parentheses. That way we still know it's multiplication. So it's going to be 5 times, and then it says the sum, which is the answer to the n plus 4. Now we haven't touched any of this yet. Okay, I just want to get this part done first, so I'm going to cross it out for now. Don't cross it out in your paper yet, but I'm just crossing it out. I'm going to erase it here in a second. Let's just make sure that this makes sense. It's 5 times, so it's 5 multiplied by, okay, that's this guy. And then we got to figure out what we're multiplying by. We're multiplying by the sum of a number and 4. That's all one big chunk, which is why I have it chunked in parentheses right there. Okay, hopefully that makes sense. Now it just, at the end here, this is pretty simple. It just says is equal to 3, so we have to set it equal to 3. Let's go to the next one. Twice the difference of a number and 7 equals 8. Difference we know is subtraction. Equals is obviously the equal sign. And then twice is just another way to say 2 times. Okay, not 2x. That's a multiplication symbol, 2 times. So it's going to be 2 times something. Well, what is it going to be? Difference. Again, this is the same type of situation as the one up top. If we're doing twice the difference of a number, that means this is the answer to a division or to a subtraction problem. Sorry, it's the answer to a subtraction problem. So if we are going twice the answer, that means we have to get the answer of that thing first. So this is going to be another case where we're going to need to do, for example, subtraction on this one before we do the multiplication. Twice the difference of a number and 7. Since number comes first, that's what I'm going to put first, n. And 7 came second, right there. And that's going to equal 8. One last time here, let me just go through it. We took twice the difference, or sorry, twice. Here's my twice, 2 times. It's being multiplied there. What are we multiplying 2 times? A lot of stuff. We're multiplying 2 times the difference of a number and 7. That's what I have here. This is the difference of a number and 7. We're taking 2, multiplying by that, it's equaling 8. Let's go to the next one. 20 more than Rhonda's height is 48. This one's actually a little bit simpler because there's no tricky parentheses on this one. 20 more than is just, well, if you're doing more than, that's addition. So this is like addition. 20 more than Rhonda's height. Let's just do an R for Rhonda's height. Is the same thing as an equal sign. 48. 20 more than Rhonda's height is 48. That's all we need for that one. Next one. 7 times a number squared is 5 times the difference of k and m. All right, this is a long one here. So 7 times, we're going to have multiplication. A number squared, that means we're going to have an exponent. Squared is exponents. Is your equal sign. So our equal sign is actually going to be in the middle of 2 different expressions this time. Multiplication again. We've got subtraction there at the end. Okay, let's start to write this out. 7 times a number squared. If I'm doing that, it's going to be 7 times. And now you could put parentheses, but I'm not going to because I know I'm going to put it right next to a number squared, which a number squared, you can do anything. Here's my number, and now it's squared. Now just looking at that, that's 7 times a number squared is equal to 5 times, now what are we multiplying the 5 by? Because in the past, we got to remember up top here, there was a chance that it would be parentheses, 5 times something in parentheses. And in this case, it is going to be in parentheses again, because again, we're taking the difference, which we set up here, remember, was the answer to a problem. So that means we have to get that answer first before we multiply it by the 5. So 5 times the difference of k and m. Difference means subtraction. The k was first, so I wrote that first. That is your answer for this one. Moving on. 15 times a number cubed subtracted from 80 is 25. Here's going to be our equal sign. Always looking for the word is. Subtracted, obviously we're going to subtract. Cubed is another exponent. We'll talk about that in a second. And then times is obviously multiplication. So we're doing 15 times. Now when it says times a number, that means we can just put our variable next to it. We know that's going to be 15 times n, right? But I don't need to write the multiplication. 15 times a number cubed. If that number is cubed, that means we have an exponent of 3. If you see the word cubed, that means we're taking it to the 3rd power. 15 times a number cubed subtracted from 80. So all of this stuff is getting subtracted from 80. Okay, all of that stuff is getting subtracted from 80, which actually changes things up. This isn't going to be the beginning of our equation. The 80 is going to have to come first. So I'm putting the 80 over there and my subtraction symbol there. Now all of this stuff that I've got highlighted is getting subtracted from that 80. Okay. We're through there. We've got our equal sign now and our 25 at the end. All right, next. 2 plus the quotient of a number and 8 is the same as 15. First of all, is the same as, this all means equals. Okay, is the same as means equals. 2 plus, that's obviously addition. Quotient. Now let's think about quotient. Again, quotient is the answer to a division problem, so we got to look for potential for like doing parentheses on that, but we'll see. quotient, good. That's all we have, I think. 2 plus, I'm going to write that first, 2 plus, so now we're adding the answer of a division problem. Now with division, we know that it's going to come before addition anyway, because of PEMDAS, right? So we really don't need parentheses to say, do the division before you do the addition, because that's just part of the rules. So let's do the division quotient of a number, n, divided by 8. I put the n on top because it came first. 8 was on the bottom because it came second. Is the same as 15. And that's the answer for that one. Again, one last time, I know I had an answer here. I know this was like in the past when we had these answers, we had to use parentheses. And this one was an answer too, we used parentheses, right? We didn't have to down here because we know division is going to come before addition anyway. So, I mean, it wouldn't like be wrong to put parentheses around it, but it's just not necessary because we know division comes first. The product of 27 and k is h squared decreased by 9. So again, we have an answer. The product of 27 and k is h squared decreased by 9. What else do we have? Is an equal sign, right? H squared, that's an exponent. Decreased is subtraction. I think that's all we've got. So the product of 27 and k, that's multiplication. So 27 and k. I don't need parentheses, even though this is an answer, just because that's the only thing that's on that side anyway. So we wouldn't need parentheses for it. There's only one operation over there. Is h squared decreased by 9. We're taking 9 away from it. That's our final answer for that. Moving on to these final ones here. It looks like I kind of went on to another page with that last one. You should have all of these 5 on one page. But anyway, translate each equation into a sentence. So if I'm translating this into a sentence, I'm just doing the opposite of what I did up top. So like you could have different answers than I'm going to have. I'm just going to go through and list what I would have. The product of 7 and m decreased by q is 23. So I'd got my multiplication in there, and I decreased it by q, and we should be good to go. On the next one, I have parentheses, so I'm going to have to use one of those words that it's talking about the answer to an addition problem. So 3 times the sum of g and 8 is the same as the product of 4 and h, running out of room, decreased by 10. All right, kind of ran out of room there. But 3 times the sum of g and 8 is the same as the product of 4 and h decreased by 10. Let's go to the next one. 6, and I don't care if you write the word out as 6 or the number 6. I might actually switch it just to be consistent, but 6 plus the product of 9 and k plus the product of 5 and j is 54. Okay, that's pretty simple. Next one. The quotient, of 3 and 2 multiplied by r decreased by t cubed is 132, is how I would write that one out. Again, there are multiple ways to all of these. And then the last one here, 15 is the same as the product of 25 and u squared plus 2. That is how I would write those out. Again, if you want to try them a different way and then check them, you're free to do that at any time. But that's just a few examples of what you could